Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. We are talking about graphs of quadratic functions. And as you may recall, the graph of every quadratic function is a parabola. And we have an example of a couple of parabolas here. Parabola can open upwards or it can open downwards. And so its vertex is either the lowest point on the parabola or it's the highest point of the parabola. And parabolas are symmetric. That is, they have the exact same shape on either side of a line, which we call the axis of symmetry. Here it is right here. It splits the parabola exactly in half, so this side is the mirror image of this side. Same thing if you're if the parabola opens down. We have the axis of symmetry, and the graph on this side is the mirror image of the graph on this side, exactly the same. Projectile motion, any object that goes in the air or is projected into the air travels in the path of a parabola. For example, this basketball. Now it doesn't go all the way, but you can see how the path is parabolic. Okay, and I got a couple other examples here. If you can see, there's going to be an apple coming out of here. See if you can watch it. Then I have a better one after that. There it goes.
That was a short shot.
Oh, it didn't shoot. Hold on, here it comes.
We'll put the cap on, and we'll spin the igniter, and it should shoot the apple.
Okay, bear with me. Here comes the apple. Sprays it in. He's going to put the pressure on. It's going to come shooting out of there. There it goes, and it traveled in a parabolic path. And then check out this cool thing. Oops, I don't want to share it with my friends. Ready? Watch this guy. Some people think this is fake, but he's going to go down a water slide. Vroom! Right into a pool. Alright, so some people are claiming that's fake, but I will tell you that, well, I don't know if it was fake or not, but it is possible. If they knew the velocity and the angle of inclination, they know that he's going to travel in a parabolic path, so they could have predicted exactly where he would land and place the pool right there. Whether it's fake, I don't know, but I do know that it is possible. Okay, so what are we going to do? Just want to make sure you understand a couple of things. Again, the vertex for a parabola that opens upward is going to be at the very bottom, and it's going to be at the very top if the parabola opens downward. The axis of symmetry, very, very important. It is given by the equation x equals negative b over 2a when we are of the form y equals ax squared plus bx plus c. That is, every part of the equation of the parabola is on one side. Not only does this give you the equation of the axis of symmetry, but it also gives you the x-coordinate here of the vertex. The x-coordinate is negative b over 2a. And we can use that to find the y-coordinate of the vertex. And we're going to do that right here. Consider the equation y equals negative 2x squared plus 12x minus 10. It is a quadratic because its greatest exponent is 2. Determine whether the parabola will be a parabola, whether the graph will be a parabola that opens upward or downward. Well, that all depends on the coefficient of the squared term. If the coefficient, I hope I spelled it right. Yeah, I did. Coefficient is, let's see, positive, then it opens up. And if it's negative, it opens down. So since this is negative, then this parabola is going to open downward. B, determine the equation of the axis of symmetry of the parabola. Well, the general form is x equals negative b over 2a. What's my A and my B? My A is -2, the coefficient of my square term. And my B is 12, because this is of the form ax squared plus bx plus c. A is -2, B is 12, and C is the constant -10, if we happen to need C, which we don't. So this would be -12 over 2 times -2, which is -12 over -4, which is 3. So x equals 3 is the equation of the axis of symmetry. So let's just say the parabola looked like that. Here's my axis of symmetry, and this would be x equals 3. Look, it's opening downwards because it's negative. And the vertex would have coordinates 3 what? Well, to find the y-coordinate, I just have to replace it in this equation. So that would be, let's see, determine the vertex of the parabola. They're asking for the coordinate here. So y would be equal to -2, replace x with 3 times 3 squared, plus 12 times 3 minus 10. And I will tell you that that is equal to 8. I cheated. I just didn't feel like working all that out. So the coordinate of my vertex is 3. What a horrible parenthesis there. 3, 8. Okay. All right. And finally, oh, no. Hold the phone, Chuck. So I just want to show you on the calculator what that looks like. -2x squared plus 12x minus 10. Very good. X equals 3, 1, 2, 3. I think you can picture going straight up right there and seeing that a vertical line through 3, or x equals 3, would certainly be the axis of symmetry, because it would cut the parabola exactly in half. And we said it was 3, 8, and if you go across here, this is the tick mark for 8, this is 9, and up here is 10. So you could see where the vertex is 3, 8. Okay, so let's go back to our table here. We'll do one more example and we will be done. Sketch the graph of the equation for y equals x squared minus 6x minus 8. Okay, so I need a graph, so that's what I did. Let's move it over here out of the way. And let's find the vertex in the equation of the axis of symmetry. So x equals -b over 2a, which in this case, let's see, a is 1 for 1x squared, b is -6, and then c is equal to 8. And we're going to use c this time, actually. So b is -6, so -6 becomes +6. All over 2 times 1, which is 6 over 2. Oops, we get 3 again, so that equals 3. So I know that the equation of my axis of symmetry is x equals 3. 1, 2, 3, 4, 5. Okay, so if I draw a line here, let's make it dashed, at x equals 3, and let's make it blue. No, let's make it pink. Why not? So 1, 2, 3, here, I'm going to do the best I can. So this is going to be my axis of symmetry right there. Okay, and the vertex is going to lie on that. Well, where is it going to lie on it? Well, I know that the x-coordinate has 3, so the y-coordinate is going to be, I'm going to replace every x in here with the x-coordinate 3, and I get 3 squared minus 6 times 3 plus 8, so this is going to be 9 minus 18 plus 8, which is going to be -1. So 3, -1 is my vertex. I'll graph this in blue. So 1, 2, 3, -1 is my vertex. Okay, so since I know the parabola is symmetric about this axis of symmetry, if I can get 1/2 of it, I can get a reasonable sketch of the whole thing. So what I'm going to do is I'm going to now find the y-intercept. Okay, where does the parabola cut the y-axis? Well, remember, to find the y-intercept, I let x equals 0 and solve for y. Why do I do that? Because every single x coordinate on the y-axis is 0. All of these, see where my pen's going? All of these points on the y-axis have a coordinate of x equal to 0. So I know that my y-intercept is going to be 0 something. Well, what is that something? Well, I replace x with 0 here to see what it would be, and I would get 0 squared minus 6 times 0 plus 8. So 0 squared is 0, 6 times 0 is 0, 0 minus 0 plus 8 is 8. So the coordinate of my y-intercept is 0, 8. So let's see, 1, 2, 3, 4, 5. I'll mark this as 5 here. 5, 6, 7, 8. There we go. So that's 8. So now I'm going to try and sketch this parabola. I always like to do sort of a dotted line here in case I mess up. Maybe I can make it a little better. So my parabola is going to look something like this. And now I'm just going to plow through there. Sorry about the mess. Remember, my vertex was 3, 1. And my y-intercept here is 0, 8. And just to be sure, let's take a look at the graph, and then you can see, oops, wrong one. Here we go. Yep, x squared minus 6x plus 8. We have a vertex of 3, negative 1, and a y-intercept of 0, 8. Let's see how good it looks compared to my sketch. Mine is clearly better. Okay, let's do that again. Amateurish. Awesomeness. Hope you enjoyed it. We'll see you next time.